Let's look at writing the equation of a tangent line at a particular point. So for this one, we're given g of x equals 1 minus x to the third. And we're asked to find the derivative at 0 and to use that to find an equation for the tangent line. So we're looking for an equation for the tangent line to the curve, and we're looking at the point 0, 1. So there's a lot going on here. The first thing that we need to do is figure out our derivative at 0. So in order to figure out our derivative at 0, that means we need to consider our formula. Our formula for the derivative is the limit as h approaches 0 of f of a plus h minus f of a all over h. Now in this case, a is 0 because we're looking for the derivative at 0. So that means our formula is going to change to the limit as h approaches 0 of f of 0 plus h minus f of 0 all over h. We could leave the a in, and what that would do is help us to create essentially a formula for the derivative, and then we could substitute the value of 0 in. In this case, I changed it because we are not looking for multiple different values. If we were finding the derivative at 0, and then the derivative at 2, and 7, and -4, then it would be more convenient to have the formula where we could just replace the a value with whatever our value for the derivative that we're looking for. But in this case, we're just doing 1. And it's a 0. Having the 0 in the equation will make the solution process a little bit more straightforward than some of the others that we've seen. Let me show you what I mean. If we're looking for f of 0 plus h, that means that we take our original equation, we take out the x, and we put instead 0 plus h. 0 plus h is just h, so solving this down gives us 1 minus h cubed. If I had left the a there, like we've done in other examples, I would have had to multiply out the cubic, and it would have been a big binomial expansion. Leaving the 0 because it's 0 makes it pretty neat and tidy. So if we look at f of 0 for the second part, that will look like 1 minus 0 cubed, which in this case will just be 1. So it's pretty straightforward in terms of our 0 plus h because it's the 0. Sometimes that works out well. So let's go ahead and substitute in what we have. So this is going to look like the limit. F of 0 plus h was 1 minus h cubed. Oops, I forgot to write as h approaches 0. There we go. Minus f of 0, which is going to just be 1 all over h. Just like before, anything that does not have an h has to cancel. So those ones cancel. Now we're left with the limit as h approaches 0 of negative h to the third over h. So we can cancel that h. This will become to the second. This one will cancel. And now we've eliminated the division by 0. Because we've eliminated the division by 0, that means we can put our h value in, and this is going to look like negative 0 squared, which is just going to be 0. So that means that our slope is equal to 0. So now we can write the equation of the line. So the equation of a line looks like y minus y1 equals m times x minus x1. This is our point slope form, and it's called that because you're using a point and you're using a slope to formulate the equation of the line. So from our point, we have our x1 and we have our y1. So x1 would be 0. Leave x because we're solving for x in the equation. Our m would be 0. y1 is 1. And leave y because we are leaving x and y in for the equation. So simplifying this down, the whole right side goes to 0. So y minus 1 equals 0. So it looks like we just get y equals 1. So this is a horizontal line. In this case, the tangent line turns out to be a horizontal line.